What is it about C that makes it the foundation of so many programming languages and systems? In this video, we'll explore how C's data types shape the way programs work, revealing the secrets behind its reliability and flexibility. Now that we've set the stage, let's preview the journey ahead. We'll start by understanding data types, move into variable declaration and format specifiers, examine sizes and ranges, and finally, explore type conversion in C. Every variable in C is defined by its data type, which determines what kind of data it can store. In this topic, we'll uncover the essential role of data types and how they shape the structure of C programs. Before we dive deeper, let's clarify what we mean by data type. A data type specifies the type of data that a variable can store, like integer, character, float, or double. This definition is central to understanding how C organizes information and ensures program reliability. Here's how C organizes its most important data types, each serving a unique purpose in program design. Integer data types store whole numbers and are declared using the int keyword. Character data types store a single character and use the char keyword. Float data types store decimal numbers and are declared with the float keyword. Double data types store decimal numbers with greater precision, using the double keyword. Void data types represent no value, and are often used for functions that do not return anything. C is a statically typed language, meaning every variable's type is fixed at declaration and remains unchanged throughout its lifetime. In C, the type of each variable must be specified when it is declared. Once a variable's type is set in C, it cannot be changed later. Declaring variables and using format specifiers are fundamental skills in C programming. This topic will show you how to define variables and display their values correctly. Here's how we declare variables of different data types in C and print their values using format specifiers. Line 4 declares an integer variable named age and assigns it the value 20. Line 5 declares a float variable named height and assigns it the value 5.7. Line 6 declares a double variable named pi and assigns it the value 3.14159. Line 7 declares a char variable named grade and assigns it the character A. Lines 8 to 11 use format specifiers to print the values of each variable. Format specifiers are essential for displaying variable values correctly in C. Each specifier matches a specific data type. The %D format specifier is used to print integer values. The %C format specifier is used to print character values. The %F format specifier is used to print float values. The %LF format specifier is used to print double values. The size and range of each data type in C can affect how much memory is used and what values can be stored. Let's explore these differences and their impact. Notice how these factors align in surprising ways. The size and range of each data type can vary depending on the system, but typical values reveal important distinctions. The int data type typically uses 4 bytes and can store values from -2,147,483,648 to 2,147,483,647. The char data type usually occupies 1 byte and can represent values from -128 to 127. The float data type typically uses 4 bytes and covers an approximate range from 3.4 times 10 to the power of -38 up to 3.4 times 10 to the power of 38. The double data type generally uses 8 bytes and can store values from about 1.7 times 10 to the power of -308 up to 1.7 times 10 to the power of 308. Here's how architecture and modifiers influence the size and range of data types, making C adaptable to different systems. The size and range of data types in C depend on the system architecture, so they may differ across platforms. Modifiers like long, short, signed, and unsigned can change the size or length of primitive data types. Here is how we use the sizeof operator to check the size of data types in C. Line 3 prints the size of the int data type. using sizeof with int. Line 4 prints the size of the char data type using sizeof with char. Line 5 prints the size of the float data type using sizeof with float. Line 6 prints the size of the double data type using sizeof with double. Type conversion allows C programs to change one data type into another, either automatically or manually. This topic reveals how conversions work and why they're important. Here's how type conversion works in C, with both automatic and manual methods, and the limits imposed by compatibility. Automatic conversion happens when the compiler changes a variable's type, if such a conversion is possible. Manual conversion occurs when the programmer explicitly changes a variable's type. Type conversion in C is only performed between data types where such a conversion is possible. Literals and constants play a key role in type conversion, as they provide fixed values that can be assigned and converted as needed. Literals are constant values assigned to variables and represent fixed values that cannot be changed. The terms constants and literals are often used interchangeably in C. Understanding data types is the foundation of writing reliable and efficient C programs. By mastering data types, variable declaration, sizes, ranges, and type conversion, you can create programs that are both robust and adaptable. The journey doesn't end here. Keep exploring and experimenting with C's powerful features.